Hey everybody, we're going to continue with the graphing polynomials section. So just remember from last video we talked about end behavior and how that can help us determine what the ends of a graph will do in a polynomial. So now we're going to use that concept to help us actually physically graph a polynomial. So I basically come up with 4 simple steps in order to graph a polynomial successfully. So you want to make sure you write these down so you can refer back to them. The first is to determine the end behavior. So you have to pay attention to your degree and your leading coefficient. And then once you've found the end behavior, then you're going to figure out the maximum number of turns a graph will have. So the easiest way to do that is take the degree of the polynomial and subtract 1. So you want to make sure you write that rule down. So for example, if your degree is 4 in a problem, then that means the max number of turns would be 3, because 4 minus 1 is 3. Now, keep in mind that just because it says the max number of turns is 3 doesn't mean it has to have 3 turns in it. Some graphs will have the full number, some graphs will have less, and it just depends on the equation that you're given. All right? And then once you've found those things, then you're going to find the y-intercept. In order to find the y-intercept, you want to make sure that you plug in x equals 0 into your equation, and then you would just go ahead and make a table of values. And once we have it graphed, we're going to talk about a few key features of each graph. So we're just going to jump right into an example. So here I have the example f of x equals x cubed minus 4x squared minus 2x plus 3. So there's a couple things we want to look at first. Step 1, the end behavior. So our degree is 3, so it's odd. And our leading coefficient is a positive 1, so that means it's going to be a positive. And just remember, if it's an odd and it's positive, your end behavior is going to go up on the right and down on the left. So we know that our graph should end by going up, and it should, on the left side, be going down. Okay, so as it goes to the right, it goes up. As it goes to the left, it goes down. So I always kind of just draw that out at first, just so you know that your graph is pointing the right direction when you're finished. Then we want to go to step 2. So step 2 said, determine the max number of terms. Well, the degree was 3, so I'm going to write that down. So the max turns that it could have would be 2. So 3 minus 1 is 2. So at a maximum, this graph should turn twice, all right? And then we get to step 3, which is to find the y-intercept. So I'm going to go ahead and plug in x equals 0 into my equation. So when I plug in 0 here, I get 0 to the third, which is just 0. Then we get minus 4 times 0, which is just 0. And then minus 2 times 0, which is 0. And then plus 3 at the end. So my y-intercept is going to be a positive 3. And if you want to put this into your table, you can. So I'm just going to make a table here, x's and y's. So one of my points is 0, 3. So now I can go ahead and I could plot that on my graph. So 1, 2, 3. So there's 1 point. And then the next thing I need to do is make a table. So that's where step 4 is. And I'll put this as step 4 here. So now I'm just going to pick some numbers. So I'm going to pick things to the right and left. Make sure you pick positives and negatives. And also another thing that's important to look at, when you look at your degree, remember this is the number of potential solutions. So remember, a solution is where it hits the x-axis. So if I know my degree is 3, that means I might have 3 solutions. Now you don't have to, okay, but or you don't have to have 3 that hit the x-axis. You might have some imaginary, but that's going to help us determine if we're finding the correct number of points. All right, so I'm going to go ahead and pick some positives and some negatives. Maybe I plug in positive 1. I'm going to pick a couple different. Maybe I pick positive 4, positive 6. Maybe I pick some negatives. So negative 2, negative 5, just picking a variety of problems, and maybe negative 8. Now, I just picked some random numbers. It's just going to depend on the graph what the best points to pick are. There's not always a rhyme or reason to the numbers that I pick. So let me just make a table. You might have to make more points than what I give you, and that's okay. So if I go ahead and plug in 1, so 1 to the third is 1, minus 4 times 1 squared is just 1, minus 2 times 1, and then plus 3. So notice I'm doing some mental math to simplify this. If you need to write all that work out, please do. So I have 1 minus 4 minus 2, and then plus 3. That's going to get me a negative 2. So I can go ahead and plot the point, 1, negative 2. So notice I had 1 point here and 1 point here. That one's above, one's below. That means that my line is going to cross the x-axis somewhere in between. So that's going to be one place where I'd have a solution. So now let's keep going. So if I plug in 4 into my equation, so 4 to the third is going to get us 64, minus 4 times 4 squared is 16, minus 2 times 4, and then plus 3. So now I can go ahead and simplify. So 64 minus 4 times 16, that's 0. Minus 2 times 4 is 8. And then plus 3, I'm going to get negative 5 here. So go to 4, down 1, 2, 3, 4, 5. Okay, so now I can go ahead and plug in 6. You guys are all very capable of plugging in numbers into a table, okay, but I just want to make sure you show your work. So 6 to the third, that's 216, and then minus 4, 6 squared is 36, minus 2 times 6, and then plus 3. So now I can go ahead and calculate all of that out, and when I do that, I get positive 63. So notice that now over here at 6, that's not a very realistic point to plot, so you could do one of two things. Know that this graph's going to go way up, okay, or you could pick another smaller point. Maybe you plug in 5 here, okay, and figure out what you'll get when you plug in 5. But remember, our goal was that we ended with our graph going up on the right. So what that means is this probably is going to start going up and up and up and up forever. I could plug in a higher point just to make sure, okay, but that's a good thing that my graph goes up. So there's going to be a turn here. Okay, so at 6, let's see, we're all the way up into the 60s, okay? Now I'm going to go ahead and plug in my negative numbers. So the one thing people make the biggest mistake on with negatives is that they don't use parentheses. So please make sure if you're plugging into a calculator that you use parentheses around your negative numbers. So if I plug in negative 2 to the third, that's going to get me negative 8, minus 4 times negative 2 squared is positive 4, minus 2 times negative 2, and then plus 3. So simplify that out. We get, let's see, minus 16, plus 4, plus 3. We get negative 17. So again, not a pretty number, so negative 2 all the way down here, down at negative 17. I can go ahead and plug in negative 5. So we get negative 5 to the third, which is going to be negative 125. Okay, minus 4 times negative 25, or negative 5 times negative 5 is positive 25, minus 2 times negative 5 plus 3. So I get negative 125 minus 4 times 25 plus 10 plus 3. That's going to be negative 212. So that's a really, really large number. So what that means is this is probably going down really far, which is good. We said it should go down on the left. So instead of plugging in negative 8, I'm going to adjust my table a little bit. Maybe I plug in negative 1, or maybe even plug in a fraction. Maybe I plug in negative 1/2. It's okay to plug in fractions, and sometimes that might actually help you. So if I plug in negative 1 here, I'll get negative 1 minus 4 times positive 1, because it changes signs, minus 2 times negative 1 plus 3. So we get negative 1 minus 4 plus 2 plus 3. We get 0. So much nicer. Okay. So now when I go ahead and I plot this, I can look at my graph. Let me scroll down just a little bit. And we knew that it has to go down forever. So when I plugged in negative 2, I got negative 17. So I know it's going down pretty quickly here. Hits my point. It's going to come up and hit my point at 0. Come up to my y-intercept. But then I have to come back to this point. So I'm going to come down, make a turn. Has to hit this point here. And then we knew that when I plugged in my 6, it went all the way up to 63, which was way up here. So my graph has to turn all the way and go up. So this is just a rough graph, okay? Obviously these are going to be an estimation because we're not plotting a million points, but your end behavior should be correct. I should see turns in a general location where they're located. And remember, we said this had a degree of 3, which means it should hit the graph potentially 3 times. So 1, 2, 3. And it said max number of turns was 2. Well, my graph turns twice, here and here. So that works. Excuse me. So this is a rough sketch of our polynomial, and then we'd be done. Obviously, these problems take a little bit of time, so make sure you follow the 4 steps. You might have to plug in more numbers than you are used to plugging in into an equation, because these graphs are different for every single equation. So the more points that you have, the better. And be very careful when you plug in negatives. That's the biggest suggestion I could give when you're doing this section. And if you need any help or you have any questions, please feel free to ask me in class. And that's it. Thanks for listening.